Today we're going to be talking about simplifying expressions and also some properties that go along with them. The first property we're going to talk about is the commutative property, which basically says you can add two numbers in either order and multiply two numbers in either order. Excuse me. So for instance, 2 plus 7 is the same as 7 plus 2. They both give you 9. 3 times 9 is the same as 9 times 3. They both give you 27. Similarly, using variables, a plus b is the same as b plus a, and a times b is the same as b times a. That's the commutative property. And the associative property, this occurs when you are only adding or multiplying. You can group any of the numbers together in any order. So for instance, 6 plus 8 plus 2. It doesn't matter if you add the 6 plus 8 first and then add the 2, or add the 8 plus 2 and then add the 6. You still get the same answer of 16 each time. Same is true with variables. If you have a plus b plus c, it doesn't matter if you add the a and b together first and then add the c, or add the b and c together first and then add the a. Any of the orders are fine. Same with multiplication. 7 times 4 times 5 is going to give you the same thing as multiplying the 7 and the 4 first, and then multiplying the 5, or multiplying the 4 and the 5 first, and then multiplying the 7. Anyway, you're going to end up with 140. Same goes for a times b times c. It doesn't matter if you multiply the a and the b together first, and then multiply the c, or multiply the b and the c together first, and then multiply the a. You get the same result. So for instance, if you want to simplify each expression, we have 1/3 times 5 times 33. Well, I know that 1/3 of 33 is 11, so I'm going to multiply those together first, because 1/3 times 33 is 11, and then I'll just multiply by the 5, which will give me 55. Just a quicker way of doing it than saying 1/3 times 5 is 5/3, 5/3 times 33, and then canceling and getting 55. Okay, so next, over here, we have 45 plus 16 plus 55. Well, I know that 16 and 4 gives me 20, and 45 and 55 gives me 100. So it really doesn't matter the order in which I add them, and I end up with 120. So that was a little quicker to just group them like that. 15 and 1/3 plus 4 plus 1 and 2/3. Well, I know that 15 and 1/3 plus 1 and 2/3 is going to give me a whole number. So I'm going to do that first. 2/3 and 1/3 give me 1. 15 and 1 gives me 16, but then I've still got this 1 over here from 1 and 2/3, and so that will give me 17 total. And then I'm going to just add the 4, which will give me 21. Over here, 1/2 times 7 times 8. I'm going to do 1/2 times 8 first, because I know half of 8 is 4. And then just multiply it by the 7, which will give me 28. So let's continue. The terms of an expression are the parts to be added or subtracted. And that's a word we're going to be using often as terms. Like terms are terms that contain the same variables raised to the same powers. Constants are also like terms. So for instance, 3x and 2x are like terms because they contain the same variables, they're raised to the same power. 7 is a constant because it's just a number. A constant is just a number. So for instance, just going back up here, some examples of like terms. If my pen will work. Okay, I think we got the pen working now. Like terms. Some examples of like terms would be, say, x squared and negative 2x squared, because they both have x squareds. Negative 7y and positive 4y, because they both have y's. Some things that are not like terms would be something like, let's say, x to the third and x to the second. Those are not like terms. They do not have the same power. Negative 4y and negative 4y to the second. Those are not like terms because the variables don't have the same power. Now you can add and subtract only like terms. So for instance, if we have 72p minus 25p, you can subtract those. And the reason you can subtract those terms is because they are like terms. They both have p's. So 72p minus 25p is 47p. If we have 3/4 x to the fourth plus x to the fourth, you can always put a 1 in front of a variable if there's no number there. That's the same as having a 1x to the fourth. So 3/4 x to the fourth plus 1x to the fourth gives you 1 3/4 x to the fourth. You can also write it as an improper fraction if you wish. 0.5m plus 2.5n. Those are not like terms, so this is as simplified as we can get them. 16p plus 84p, those are like terms, so we will add them and get 100p. Next, negative 20t minus 8.5t. They are like terms, they both have t's, so we get negative 28.5t. 3m to the second plus m to the third. Those are unlike terms because the powers are not the same on the variables. So this is as simplified as we can get it. Let's move on. The distributive property. If you have two numbers that are being added or subtracted in parentheses and they are being multiplied, what you do is distribute the multiplication to each term inside. A times B equals AB, and A times C equals AC. That should be an A right there, so let's change that. So AB plus AC, that was a typo. Okay, so now let's simplify. We want to take care of our parentheses first. We have 2 plus x inside of the parentheses. They're being multiplied by 4. 4 times 2 gives you 8. 4 times x gives you 4x. Now, we can add everything together. That's a like term. For like terms, we have 14x plus 4x. That gives you 18x plus 8. Let's continue with the next one. We want to get rid of the parentheses, so we're going to distribute 6 times x and 6 times negative 4. Think of it as a negative 4. Negative 4 minus 4, same idea. 6 times x is 6x. 6 times negative 4 is negative 24. So it is going to be a minus 24 because it's negative. Then we'll add 9. The like terms we have are these constants, these plain old numbers here. Negative 24 plus 9. So if you take negative 24 plus 9, we get negative 15. So we end up with 6x minus 15, and those can't be combined anymore. Next, we have negative 12x minus 5x plus x. We've got 3 like terms here, so we need to combine those. You can think of this as a 1x if you want. Excuse me. Negative 12x minus 5x is negative 17x. And then you have to add this 1x onto it, so we get negative 16x. We still have this plus 3a hanging around, so we need to bring that down. And this is as simplified as we can get this. Thank you very much for joining me.